Welcome to Section 10, Lesson 3. Adding and subtracting radicals follows the same rule as combining. Like terms in polynomials, the parts have to match before you can combine them. For radicals, matching means same index and same radicand. Like radicals are the radical analog of like terms. 3 root 2 and 5 root 2 are like, the coefficients are different, but the radical part is identical. 3 root 2 and 4 root 3 are not like, because the radicands 2 and 3 are different. The procedure is one step. Once you have like radicals, add or subtract their coefficients while keeping the radical unchanged. The radical itself does not change, only the multiplier in front does. Sometimes radicals do not look like at first glance but become like after simplification. Always simplify each radical to its canonical form before checking for like terms. The simplified form makes any combinations obvious. Take 3 root 2 plus 5 root 2 minus root 2. All three terms have the same radical, the square root of 2. The coefficients are 3, 5, and 1. Each term is a multiple of root 2. The number line below shows where 3 root 2 and 5 root 2 land. The answer will land at 7 root 2. Further to the right, combine the coefficients. 3 plus 5 minus 1 equals 7. The radical itself stays unchanged. The expression equals 7 times the square root of 2, written 7 root 2. Verify on the number line. 7 root 2 is approximately 9.9, between 9 and 10. The single dot at 7 root 2 replaces the three separate dots at 3 root 2 and 5 root 2. Example 1. Simplify the square root of 50 plus the square root of 8 minus the square root of 18. The radicals look unlike at first, but each one simplifies to a multiple of the square root of 2. Simplify each radical. Square root of 50 equals 5 root 2, since 50 equals 20, 5 times 2. Square root of 8 equals 2 root 2. Square root of 18 equals 3 root 2. Now all three are like radicals. Combine the coefficients. 5 plus 2 minus 3 equals 4. The radical part stays as the square root of 2. The simplified expression is 4 root 2. Without the simplify first step, the original expression looks like a sum of three different radicals. After simplification, the structure reveals itself as a single multiple of root 2. Example 2. Simplify the square root of 12 plus the square root of 20, 7 plus the square root of 50. After simplifying, you may have unlike radicals that cannot be combined further. Simplify each. Square root of 12 equals 2 root 3. Square root of 27 equals 3 root 3. Square root of 50 equals 5 root 2. Identify like radicals. The first two are both multiples of root 3. Combine them. The last is a multiple of root 2 and stays separate. 2 plus 3 equals 5, so the root 3 terms combine to 5 root 3. The simplified expression is 5 root 3 plus 5 root 2. Two unlike radicals cannot be combined into a single radical. The answer stays as a sum. That is the canonical form. Simplify each radical, combine like once, and stop. 3 takeaways for adding and subtracting radicals. They mirror the rules for combining like terms. Two radicals are alike only when both the index and the radicand match. Same index means both are square roots, both cube roots, etc. Same radicand means the same number under the radical. Mismatch on either side means the radicals are unlike and cannot combine. When radicals are alike, combining is just adding or subtracting their coefficients. The radical part is treated as a single unit, like a variable in a polynomial. 3 root 2 plus 5 root 2 equals 8 root 2, exactly the same way 3x plus 5x equals 8x. Always simplify each radical to canonical form before deciding whether terms are like. Many problems hide like radicals inside non-canonical forms. Simplifying first turns the apparent unlike sum into a clear addition of like radicals ready to combine.